All right, here is your Unit 5 test review. They're all systems, so even though you only see one line here, it's because the system, they're right on top of each other. And if it's right on top of each other, they're intersecting every single place that they're touching. So therefore, there's infinitely many solutions. We can't physically identify every single one because lines go on for forever. So they're touching everywhere that line passes. Next one is identify the solution of this system. They're intersecting one time. So we have to name that coordinate right there. So remember, when you're graphing coordinates, there's always an x and a y. X is left and right, like the axis. Y's are up and down, like the y-axis. So I went left 3, up 4. So since I went left 3, right here's your negative 3. I'm going to start off with a negative 3, like this one right here, and I went up 4. So my order pair is 3, 4. And see, that 4 is positive. So left 3, up 4. 3 is negative, 4 is positive. 3 is negative because you went to the left, 4 is positive because you went up compared to going down. Okay? So your answer should be B here. Next one, you're going to have to graph these. So when I'm graphing them, the first one I'm going to do in blue, the y-intercept is 2. So I'm going to start off at 2. The slope is negative 1 over 3. So remember, rise over run. So I'm going to rise negative 1, which means I'm going to go down 1, and I'm going to run 3. 3 is positive, positive numbers to the right. 1, 2, 3. Okay? I could also go up 1, left 1, 2, 3. And when I have this line right here, I see that it's a decreasing line, which is good because the slope of this line is negative, so it should be decreasing. So that's a check you should always do when graphing lines. Next one, we're starting at negative 3 on the y-axis, and my slope is negative 2. It's not written on as a fraction, but we can always write any whole number over 1. Once again, rise over run. So I'm going to rise in negative 2, so really fall 2, and I'm going to run 1 in the positive direction. Or I can go up 2, left 1, up 2, left 1, up 2, left 1, until they finally hit each other right there. Same thing, negative slope, that line's decreasing, okay? If I was to draw that little guy right there, he'd be falling down that ski slope, okay? He wouldn't be going up. It's a decreasing line. They intersect at the coordinate negative 3, positive 3, which is answer choice C. If you are not very comfortable graphing lines, then don't forget you can always go to your calculator, type them in. So go to y equals, here they are typed in, negative 1/3 x plus 2 and negative 2x plus 3. You can graph it. If they don't automatically appear on your screen and someone's been messing with your calculator, what you'll want to do is go to zoom 6 and now readjust what's happening. Now, whoever's been messing with this calculator before me, they turned off the equal sign. That's why you didn't see anything. It was graphs. So I have to go back and make sure they're turned on, okay? So let's try that again. Here's the first one, which is the blue one that we have right there. And here's the second one, which is the red one, which is right there. Okay, so if I want to find their intersection, second, calc, 5, enter, enter, enter. And if you look at the bottom of the screen, negative 3, 3. So if you wanted to, you didn't even want to graph it, you could have just skipped right to there since it's a multiple choice test. Next one, you got a couple different ways you can do this. You can solve it by graphing, you can solve it by elimination or substitution. It's set up for elimination because the x's are above the x's, y's are above y's, numbers are numbers. But I did the elimination in class, so I'm going to do it differently in case you're watching this video, so you have different options, and I'm going to do this one by graphing, okay? So we got two equations, x plus 2y equals negative 8. We're going to solve for y, so I'm going to have to subtract x first. 2y equals negative x minus 8 because those two pieces right there are not like terms. I'm going to undo this multiplication by dividing by 2. Rocket science, negative 1 over 2x plus negative 8 divided by 2. Clean it up, negative 1/2 x, and negative 8 divided by 2 is negative 4. There's an understood 1 in front of that x. That's where that 1 came from when I did rocket science. So there's my first one. I'm going to start at negative 4 because that's my y-intercept, and I'm going to go down 1 right 2 because my slope is negative 1 over 2. So I'm going to rise a negative 1, and I'm going to run a positive 2. Down 1, positive 2. Or up 1, left 2. Up 1, left 2. And that'll give me this line right here. And notice my line is decreasing, and when it's in slope-intercept form, I have a negative slope. So I've done something right so far. Next one, 3x minus y equals negative 3. I'm going to subtract 3x, PEMDAS backwards, got to undo the addition or subtraction to y. Those cancel, you're left with negative y equals negative 3x minus 3. And there's an understood 1 in front of that y right there. So I'm going to divide by negative 1 to undo that multiplication. This cancels, you get y equals negative, or rocket science now, so negative 3x over negative 1 and negative 3 over negative 1. Clean it up. Negative divided by negative is a positive 3x. Negative divided by negative is a positive 3. So I'm going to start right here at a positive 3 because that's my y-intercept. My slope is 3 over 1 since there's not already a fraction there. So I'm going to rise 3 and I'm going to run 1. So up 1, 2. I can't actually go up 3. So remember, you can kind of think of it as two negatives make a positive. I can go down 1, 2, 3, left 1. Down 1, 2, 3, left 1. And then here's my line right here. So when I'm looking at it, I still went up 3, right 1, and it's an increasing line, which is good because I have a positive slope. So my answer here is negative 2, negative 3. Same thing as last time. If you wanted to, you could type those two pieces in the calculator, this, and do second, calc, 5, enter, and that would also give you the same answer. So if you want to see that, here we go. We got negative 1 over 2x minus 4, and the next one is 3x plus 3. Got them typed in, you go to graph. There's the first one. That's the blue one we have right there, and the second one's going to be the red one we have right here. So if I want to find that intersection right there, second, calc, option 5 says intersect, enter. And at the bottom it says negative 2, negative 3, which is exactly what we have on our answer choice right there. So that's how you don't miss those. You check them in your calculator, okay? And I'm going to show you another method later on in the movie, or, the video clip. Next one right here, which the following is a solution. This one's, you can use elimination, graphing, or you can use substitution. This one's set up for substitution, okay? So you see right here, there's y. It's like the Julio Jones problems we did in class. So everyone needs a substitution, or substitute. So Julio Jones right there, it's in the game, he's going to come out and his substitute's going to come instead. So we have 2x minus 7. Here's a substitute. His substitute is x plus 3. Okay, so he replaced the y in the equation. So if his substitute comes out, a new wide receiver goes in. Okay, now what we're going to do is start solving this for x. So I'm going to have to distribute this negative 7 to both pieces. Negative 7x, negative 7 times 3 is negative 21, and it equals 14. I can combine like terms, which is going to give me a negative 5x minus 21. And now I can solve for x by undoing the subtraction. So PEMDAS backwards, adding 21 to both sides, and get negative 5x equals 35. Solve for x by dividing both sides by negative 5, and x equals negative 7. Luckily, there's only one answer that has negative 7 in it as the x part, because this one's negative 3, 7, 0. So we know the answer should be D, but let's continue working it out just in case. I'm going to substitute the negative 7 into either equation. The bottom one's going to be easier because it's already solved for y. So I'm going to replace x with a negative 7, and negative 7 plus 3, y is going to equal negative 4, which is correct. Okay, now here's how you check these to make sure you get 100 tomorrow, okay? So what I can do is I'm going to check this ordered pair, negative 7 to negative 4. The x is negative 7, and the negative 4 is y, okay? So I'm going to retype this equation, but instead of typing an x, I'm going to do a negative 7 minus 7. Instead of typing a y, I'm going to do a negative 4, and I want to make sure that equals 14. So I made it through security, and I'm going to do the same thing again. X plus 3, instead of x, I'm going to do negative 4 plus 3, and I want it to equal the y value, or erase for a second. The x part is negative 7 plus 3, and I want it to equal the y value, which we're saying the y value is negative 4. And it does equal it. So check, we made it through customs and security, so we make it on the plane, and that's how you know you got that answer right. Okay, on the back, same thing. These are set up for elimination. Very pretty, because look, you've got a negative 4x and a 4x. You've already got inverse coefficients. So what you can do is you can start off by just adding them together. So I'm going to rewrite it over here so I've got room to work it out. Well, 4x minus 4y equals 16. Now I'm going to add them together. So negative 4x plus 4x adds up to 0. Negative 2 minus 4, check it in your calculator, adds negative 6y. And negative 10 plus 16 is going to add up to 6. So we have 0 minus 6y equals 6. Which we don't really need the 0 because we know 0 minus something is going to stay exactly how it is. So I'm going to solve for y by dividing by negative 6. And y equals negative 1. So negative 1 is going to definitely work. D is the only answer with negative 1, but I'm going to tell you got to be cautious when you have infinite solutions because there's a possibility more of them could work than just D. But whenever you work this part out, once the second you get a number, there's only one solution. So our backfall method, our safety net, like just plugging them in until they work, you got to be careful about plugging them in until they work just because infinite solutions you technically can't just plug in. But we know we're right because when we solved, we got y equals negative 1. So therefore, we know there's going to be one solution. But I'm going to keep going. I'm going to finish the x part, okay? So I'm going to substitute it back into either equation. I'm going to pick the top one. So I'm going to replace y with a negative 1, and I'm going to solve. So 4x, negative 4 times negative 1 is going to be a positive 4. I'm going to undo addition by subtracting it from both sides, and I get 4x equals 12. Divide by 4, and x equals 3. And once again, that's the correct answer. So if we wanted to check it, here's how we would do it. Negative 4, parentheses 3, minus 2, parentheses my y value, which is negative 1, equals negative 10, so I'm good. Let's try it again. 4 times instead of x, put a 3. Minus 4 instead of y, put a negative 1. And it comes out to be 16. So I checked for both of them. Okay, same thing for the next one. When I'm looking at this, I see the y and the y's, one's positive, one's negative. I want them both to be 3. So I'm going to multiply the top one by 3. So 3 times negative 9x is negative 27x plus 3y equals negative 48. I'm going to rewrite the bottom part and add them together. So negative 27 minus 18 or plus the negative 18 is negative 45x plus 0 equals negative 45. I don't need the plus 0 because that's the same thing as just the plain negative 45x. So now I can divide both sides by negative 45 and x equals a positive 1. Okay, only answer that has a positive 1 is D. So I could stop if I wanted to, but once again I'm going to continue finishing it, okay? So I'm going to substitute in the top equation. So negative 9x plus y equals negative 16. I'm going to do negative 9 times 1 instead of that x because I'm replacing the x with a positive 1. Okay, negative 9 times 1 is negative 9. I'm going to add 9 to both sides to undo that negative 9 being added, and those cancel. I'm left with y equals negative 7. So once again, you can check this by doing your safety net or your airplane examples to make sure you're right. Next one, I'm trying to rush because flex is about to happen. But looking right here, what's the first step? Well, when I'm looking at them, I want them to be the same. So either these both need to be 6 or these both need to be 5 because those are least common multiples. So that one's already 5. I would multiply the bottom one by a negative 5. So that way they add up to 0. If you do a positive 5, they're going to add up to 10. So don't get fooled by that tomorrow. Next one, Kayla's school selling tickets to a choral performance. On the first day, tickets sold 2 adult tickets, 1 child ticket for 31. Okay, I'm going to let A be adult, C be child. So I heard 2 adult tickets plus 1 child ticket, and it's going to total out to be 31. Okay, the second day, they took in $51 by selling 4 adult tickets, 1 child ticket. So I hear 4 adults plus 1 child, and that equals a total of $51 for the night. Now, when I'm looking at my answers, A is going to be the answer. But look, notice they didn't put the 1 in front of C. That means the exact same thing. You don't technically need the 1 in front of C because 1 times C is C. So don't be fooled by that tomorrow, okay? Your answer's still there. All right, let's see how much we can get through this one before the bell rings. So when we're reading this, we've got Alyssa sold 5 New York style cheesecakes and 2 marble cheesecakes for 63. So I hear 5N plus 2M equals 63. I'm going to let marble be M, and I'm going to let N be the New York cheesecake, okay? So that's what I have. So now the next one, Scott sold 5 New York, and he also sold 6 marble. And it came out to be a total of 119. Okay, now some people said I use an E and an S for Alyssa and Scott. However, the bottom question says, what's the cost of New York style cheesecake and chocolate marble? We don't even care about Alyssa or Scott. That's just what we kind of had to use in order to find the answer. So now when I'm looking at this, I'm going to solve by using the elimination method because it's already set up for it. So I'm looking at these. I love those 5s, but I need one of them to be negative. So I'm going to multiply this one by a -1. So that way I'll have a +5 and a negative 5 in. So I'm going to rewrite the top. Sorry, messed up there. And I'm going to distribute the -1. -5m, -6m equals -119. Add them together, those cancel, and you're left with -4m equals, I would check in my calculator, but it is 63 minus 119, which is -56. Divide by -4 to solve for m, and m equals 14. So when I'm looking at this marble cheesecake 14, that's going to be the only one that works. However, let's go ahead and solve for the other piece while I've got 1 minute to spare. Okay, so 5n plus 2, instead of m, I'm going to put 14 equals 63. So 5n plus 28 equals 63. Subtract 28 and you get 5n equals 35. Divide by 5 and n equals 7. I know that's rushed.